Okay, so in the last video we looked at roots and exponents with numbers. So we saw things like the square root of 64. The square root means that we have to have two matching factors. So that would be like 8 times 8. So if you have two matching factors, then the square root, the answer is a 1 factor. And if you have the cube root, let's say we have the cube root of 125, then you're looking for 3 matching factors. So that would be like 5 times 5 times 5. So if you have 3 matching factors, then the answer would be 5. So if you have square root, you're looking for 2. If you're cube root, you're looking for 3. If it's got fourth root, then you're looking for 4, and so on. So it's the same idea with variables. It's actually a little bit easier because you don't have to figure out what these numbers are. You're already given the variable. So let's say we have like the square root of x squared. So we're looking for two matching things. Well, x squared means x times x. So the square root of x squared would just be x. And if we had the square root of x to the fourth, then that would be x squared times x squared, which would be x squared. And if we had the square root of x to the sixth, you might see the pattern here. If I broke this up into two equal pieces, it would be x to the third times x to the third. Remember, when you multiply things with matching bases, you add the exponents. So if I break up 6, it would be 3 and 3, and the square root would give us x to the third. And so on if we did x to the 8th. So you can probably see here we're taking half of the exponent each time. So the square root takes half of the exponent, half the exponent, half the exponent. So if we do cube root, similar idea. So if we have cube root of x to the third, we're looking for 3 matching factors. That's like taking a third. So if you have cube root of x to the third, that would be x. If you had the cube root of x to the sixth, then you're looking for 3 factors that break up. That would be x squared, x squared, x squared, because when we add those together, we would get 6. Or in other words, you're taking a third. Okay, so the cube root takes a third of the exponent each time. So if we have the cube root of x to the ninth, take a third of that, you would get x to the third. You don't even have to write all that out. And then similarly, the fourth root would break things up into fourths. So you need 4 equal factors. So like this, x times x times x. So the fourth root of x to the fourth would be x. The fourth root of x to the 8th, that would break us up as x squared, x squared, x squared, x squared. So this time we're taking a fourth of all of the exponents. Okay, so we're looking for equal factors, but when you're looking at exponents, you're already given the factors the base of the exponent, and you're just taking a fraction of the exponent. The root is actually a fraction. All right, so let's put this together with what we did before. Actually, before we do that, let's talk about what happens if it doesn't divide in evenly. So for all of these, we were able to divide it out. What if we had like square root of x to the 7th? So we said before you would take half of the exponent, but we can't do that here because we would end up with a fraction. So what you need to do, like we saw before, if you can't take the full root, you break it up into things you can do. So I can't do x to the 7th, but I could do x to the 6th. So x to the 7th is the same as x to the 6 times x. That gives me a total of 7. And I can break it up as x to the 6 times x this way. And I can take the square root of x to the 6. I can take half of that. I get x cubed with a square root of x left over. Okay, so if you can't divide in evenly, try to break it up into things you can. So if we had like x to the 11th, okay, I can't take half of 11, but I could do 10. The biggest I could do it, the biggest even number would be 10. It'd be 1 less than that. So I could break this up as x to the 10th and x. I can take half of 10. That would give me x to the 5th, and I would have 1x left over. Okay, so for square roots, the most you're going to have left over is 1x, because you can go into any even number. All right, and then for x to the for the cube root, let's say we have cube root of x to the 5th. All right, 3 doesn't go into 5. The best I could do is 3 into 3. And that would give me 2 left over. So x cubed times x squared would give me x to the 5th. So I can do the biggest exponent that I could do is 3. That would leave me with 2 left over. Cube root of x cubed would be x, and I would be left with cube root of x squared. All right, let's try another one of those. Let's say we have cube root of, let's say x to the 10th. All right, so 3 doesn't go into 10. The biggest multiple I could fit in there is 9. So I could do the cube root of x to the 9th. And that would leave me with 1 left over, because 9 plus 1 would give me 10. So cube root of x to the 9th, I would take the 3rd and get x cubed. And then I would have a cube root of x left over. And that looks a little weird because we've got like an exponent next to a root. Just if you're writing it out by hand, just try to make it as clear as possible. And if you're in the, like on the computer, just go with the formatting that they're giving you, and they should make it clear. All right, and let's try a 4th root. So let's say we have the 4th root of, let's do x to the 17th. Okay, 4th root of x to the 17th. So 4 doesn't go into 17. The closest I could do is 16. So I could do the 4th root of x to the 16th with 1 left over. 16 plus 1 would make 7. Sorry. Okay, so I would take a 4th here, and I would get x to the 4th for the first part. And then I would have 1 4th root of x left over. Okay, so each time you're taking out the biggest thing that you can and then seeing what you have left over. All right, so let's put this together with what we did with numbers before. So let's say that we've got the square root of, let's do 12a cubed b to the 4th. All right, so we want to simplify this as much as we can. And we're back to square roots now, so we need 2 things that multiply together, or we're looking at half of the exponent. So for 12, I can't take the square root of 12, but I could take the square root of 4, so I can break up 12 as 4 and 3. Now when we did this before, we put them side by side. I'm going to actually separate them. I'm going to regroup this, and I can do that because this is all multiplication. So I'm going to put the square root of 4 over here, and I'm going to put the square root of 3 over here. This is going to be like my leftover pile. So on the left, I'm going to put all the things I can take the square root of, and then on the right, I'm going to put together all the things I can't take the square root of. All right, so we broke up 12 as 4 and 3. I can't take the square root of a cubed, but I can do a squared, and that will leave me with 1a left over. And then b to the 4th, I can take the square root of that, and then I would have no b's left over. All right, so break it up into things that you can take the root of, things that you can't take the root of, and then simplify. So square root of 4 is 2. Square root of a squared is a. Square root of b to the 4th is b squared. I'm taking half of all these exponents. And that leaves me with square root of 3a that I can't do anything with. All right, let's try another square root one since they're the most common. Let's say we have square root of 75 x to the 5th, y to the 3rd. Okay, I can't take the square root of 75, but I can do the square root of 25. So that would be 25 times 3. So I can take the square root of 25. I can't take the square root of 3. That's going to be my leftover pile. I can't do the square root of x to the 5th, but I can do x to the 4th and 1 left over. And then y to the 3rd I can't do, but I can do y squared and 1 left over. All right, so now we can simplify. So square root of 25 is 5. Square root of x to the 4th is x squared. Square root of y squared is y. And our leftover is square root of 3xy. And just check your leftover and make sure that you don't have anything else that you can reduce. Maybe you didn't take out the biggest thing that you could. Just double check that, but it should be something that you cannot reduce. Okay, so that's what square roots look like. Let's try a cube root. Let's say we've got cube root of 16 m to the 5th n to the 7th. Sorry, that's the cat. All right. So now for cube root, we're looking for 3 matching factors, or we're taking a third of the exponent. All right, so I can't take the cube root of 16, but 16 is 2 times 2 times 2 times 2. So I could do 8 times 2. I can take the cube root of 8. So 16 I'm going to break up as 8 and 2. Okay, so 8 and 2. I cannot take a third of 5. I can't divide 3 into 5. So I could do m to the third. That I can simplify, and that would leave me 2 left over in my leftover pile. Okay, so I have a total of 5. I can do the cube root of 3 of them and 2 in the leftover pile. And then for n to the 7th, 3 doesn't go into 7, but I could do 6. And that would leave me 1 in the leftover pile. All right, and then we simplify. So then we would have cube root of 8 is 2. Cube root of m cubed is m. Cube root of n to the 6th, now remember we're taking a third, so this would be n squared. And then our leftover pile, cube root of 2m squared n. Okay, so that's for cube root. You're trying to find 3 matching factors or take a third of the exponent. All right, and if we try one with the 4th root, see if we can do this before the video cuts off. Let's say we've got 81 a to the 9th, b to the 10th. Okay, so now we're looking for 4 matching factors. There's not that many fourth roots or exponents to the 4 that are reasonable to use. So 2 to the 4th is 16, 3 to the 4th is 81. Those are the most common that you want to look for first. Okay, so I actually can take the 4th root of 81. Because 81 is 3 times 3 times 3 times 3, or 9 times 9, which breaks up as 3 times 3 times 3 times 3. So I can take the 4th root of 81, nothing left over. Now I'm trying to do a 4th of the exponents. So I can't do a to the 9th, but I can do a to the 8th. And I can't do b to the 10th, but I could do b to the 8th. Oh, sorry, I should be keeping track of leftovers as I go. So I can't do a to the 9th, but I can do a to the 8th with 1 left over. And I can't do b to the 10, but I can do b to the 8 with 2 left over. And then we can simplify. So the 4th root of 81 we said was 3. 4th root of a to the 8th, now we're taking a 4th. That would be a squared. 4th root of b to the 8th is also b squared. And our leftover pile is the 4th root of ab squared. Okay, so that's the basic idea, not too similar from the numbers that we looked at last time. Just remember the difference between square root, third root, fourth root, and so on.